we certainly need to use simplifications to be able to make progress in understanding complex systems. But we have to understand the limitations of simplifications as well. And so one of our simplifications, when we looked at infiltration, for example, was that the infiltrating front is a nice, homogeneous, smooth feature. So that the water is moving, that it's moving in a uniform advancement. This, it turns out, can be limited. And so what I want to talk about now is fingered flow. And here on my side, I've shown an experiment of fingered flow. And this is really a little bit of a complicated experiment. I'll tell you about it briefly. What happens is we have a uniform sand, and we're spraying water over the top, and we generated a flow system. Then we let it dry for a month and reinitiated the flow. And what we're seeing now are the flow patterns in that second infiltration process, where the red colors show high water content, and the darker and darker blue colors show lower and lower water content. So again, up to black at the surface. So we see the surface of the sand was really, really dry. Then it had a little residual water in the middle section and greater residual water where the drying front was coming down. So what we see in this picture are these fingers of flow. They're approximately 2 centimeters wide in this case, that are leaving most of the soil unwetted. So what does that mean? That means that if we put on water, that the movement of water will be much faster than we'd otherwise expect. It'll go vertically much more quickly, and it will leave less water behind, for example, if you're trying to irrigate. Certainly, when we're looking at like contaminant transport, what would be the implications of this fingered flow? Well, the fingers are going to, again, provide much higher velocities to the groundwater. And so in the case of Connecticut, for example, in the early studies done by Yves Parlange and Dr. Starr back in the 1970s, they were able to identify that the gravelly, sandy textures of soils in Connecticut gave rise to this fingered flow, which gave rise to the delivery of pesticides to the aquifers much more rapidly than had otherwise been expected. Some interesting features is that these fingers, after they've been formed, even if you wait for months, as long as the soil does not completely dry out, they are remembered. So there's a trace of those fingers that are remembered in the soil due to a process based on hysteresis. And so when the water comes down again, it then goes right into those old fingers. And so there's a very long-term impact of these fingers. And we've seen some sites where the fingers of flow have not dried over millennia, and so actually the rocks within the fingers can be crushed because they've been reduced to skeletal rocks due to all the infiltration, whereas right adjacent to the finger, the rocks are firm. So we have this flow process which affects only coarse textured materials, sands, coarse sands, gravels. But what it really does is illustrates how easy it is for our assumptions to be violated in dramatic ways that have dramatic implications in terms of contaminant transport, soil development, and management of agricultural soils. So this is a little case study of fingered flow, which is one in the larger category of preferential flow processes where water preferentially goes quickly, whereas had it been homogeneous flow, it would have gone more slowly.